Hello everyone, my name is Daniel Camilleri. I am the CEO and founder of a company called BO, and what we do is robot agnostic software. Next slide, please. What we want to focus on in the proposal we're putting forward is that currently around demining efforts, they rely on two different systems. First one is a mechanical flail system that is quick and dirty, which causes detonation that significantly pollutes the area, and it makes it difficult to use that area afterwards, especially for agriculture. And this method is only used during wartime. And the second one that's available today is manual demining. You send people out into the field, slowly searching through and going through the whole area, trying to find mines that they can decommission and remove. So what we're proposing for this project is an alternative approach that involves a swarm of semi-autonomous robots that do the searching with then the use of low latency teleoperation to perform the decommissioning safely and remotely. Next slide, please. So a bit about us as a company. Our vision is to democratize access to robotics software development. What we've created is a software that allows for the universal control of robots. So we're able to abstract away the differences of any type of robot, regardless of the form factor it has, be it a humanoid, a drone, a ground vehicle, or even underwater ROVs, and enable them to be controlled universally from any operating system and any programming language, rather than forcing the use of Linux and maybe Python or C++, which is the norm today. We already support 16 of the most commonly available robots, and that's thanks to our patent pending data structure that provides this abstraction. Next slide, please. As part of the SDK, we also provide low latency communication. I'm guessing the GIF isn't running, but to give you a background on what's happening there, on the right, that's myself in Toronto with an off-the-shelf VR headset connected to a robot in Sheffield performing cup stacking, a simple but dexterous task that requires fine control. And that's all done over the internet with just 10 megabits of bandwidth over the conference Wi-Fi network. And we are able to control robots like this with ultra low latency, around 150 milliseconds round trip, which allows us to directly control robots through teleoperation. Next slide. So the problem we want to address is that of demining. There are about 10 million mines today that affect 64 different countries and contribute to over 1,000 deaths per month. And mechanical clear-up methods, the flail with the chains, that achieves about 500 square meters per machine per day, but contaminates the area and is only used during wartime. And manual demining achieves anywhere between 10 to 50 square meters a day, depending on the concentration of the mines and how difficult they are to decommission. So the problem here is that this isn't scalable from a manual demining perspective because there is just way too much area to go through. And the manual demining process requires about 80 to 90% of the time just spent searching for a mine, and then the rest on the actual decommissioning. So what we're proposing is robot demining. Send a fleet of semi-autonomous robots that are able to search the area, find the mines, and once found, they stay there, send a message back to the operator, and when the operator is available, that he takes over control and remotely and safely carries out the decommissioning of that mine. Next slide, please. Now, there is hardware that has the dexterity to do it, although it's not being deployed specifically for this use case. But the problem is that it is very expensive to buy. A robot like the one shown in the picture there costs about $500,000. So what we want to do is we want to build a solution that costs less than $100,000, and that's possible through the companies that have joined this consortium so far. So to achieve this, the companies and us will put together a bimanual robotic system with very high levels of dexterity that is able to be controlled completely remotely from anywhere in the world. As I've said before, this would enable the robots to carry out the search phase of the demining procedure using a variety of sensors, from metal detectors to ground-penetrating radar. And once they find a mine, they send a message to the operator indicating that there is a mine available. The great thing is that, yes, we'd be initially creating this platform and software combination for demining, but the same robot, given our robot agnostic nature, can be used to can be adapted for different domains. Demining, agriculture, logistics. And what we'll be doing as part of the project is developing the onboard AI capabilities that permit the robot to learn by demonstration from the operator's input to increase the adaptability and performance of that robot. Next slide. What we're proposing is a decentralized distributed AI across different robots that collects data when an operator is carrying out the decommissioning procedure. The training data can then be combined universally, even if we have different types of robots in the field. All of that data can be combined into a single corpus, and that corpus can then be used to improve the AI, but more importantly, to train more humans to carry out these procedures. Next slide. The first partner that we're bringing in, and the key partner here, is Sarcomere Dynamics. They're bringing in a highly dexterous hands that they've developed in-house that is capable of operating in really rugged environments, thanks to the use of shape memory alloys as the driving force for the fingers instead of motors, making it possible to use this in wet environments. And they're also a veteran-founded company in Canada that has immediate access to subject matter expertise in explosive ordnance disposal. And this will be very useful in addressing and filling any knowledge gaps we have within this area. Next slide. The second partner is Autonomy Co. They specialize in autonomous navigation platforms that have to date been used within warehouses, but they're now being adapted for rugged and GPS-denied environments to enable us to fulfill this project. Their technology is integral then to the successful navigation of a robotic swarm, especially in unstructured terrains. Next slide. So to date, we are in combination 3 partners from 2 countries, and we're looking at an opportunity for further academic or industrial collaboration, notably with entities from Germany, Ukraine, or Poland with this case, because they might be a bit closer to the problem than we are. And we're also interested in solution backers or communication companies that can provide Open RAN or mobile 5G, 6G mesh network capabilities. Then outside of this proposal, we're also very open to collaborate with any other projects that can benefit from our expertise in robotics and low latency telepresence. So please do get in touch. Next slide. Do get in touch with myself on my email there, and very happy to have a call and talk more about the technical aspects of the company and how we've simplified the development of robotic software. Thank you.